So this problem is called single number. It is given a non-empty array of integer, and every element will appear twice except one. So the purpose is to just return the single one. Let's look at the example. So given three integers, so we say that those two are actually same. So we need to output the 1. And the second example, the same. There's these two digits are the same, and these two are the same. So we need to output 4. So how to solve it? The first solution is to iterate each item and check if it is unique. For example, we have 5 items. We first visit the first item and compare this one to other items. If none of them are equal, this is the single number. We just need to return it. Otherwise, we have to move the next item and check till we found the single number. This solution looks very straightforward, but the problem is that it is very time consuming. Actually, the time complexity is n squared. Solution 2. We firstly scan this array, and for each item, we will record the occurrence. For example, when we visit the first one, we will put it in a dictionary, say 1 happened once, and then move to the next item, which is 1. So we update the occurrence to be 2, and the third one, which is here, which is 2, occurred once. Then the fourth time, it will be 2, then update this 2 occurrence to be 2. And then for the last one, which is 3, and it's occurred once. So the second time, we scan this dictionary and found out the item which only occurred once, which is 3. So this is a single number. So this solution, the time complexity is actually n, which is quite an improvement against solution 1. However, the space complexity, because we need to save it in a dictionary, which is n2. So that is solution 2. Let's take a look at the code. So firstly, it initializes the dictionary, and for each item in this list, it will update the occurrence. So this one here is just in case it is the first time we get I, and then because there's no item in the dictionary, so we give the default value, which is 0. And secondly, then for each dictionary, we just check if the occurrence is equal to 1. If it is equal to 1, we just return it. The third solution is using bitwise operation, which is XOR. So we know that if the same number, if we XOR it, it will be 0. And if 0 XOR a number b, which will be b. So imagine that if we XOR all the items in the list, then all the pairs will return to 0, and then the single number will be the result. Let's take a look at the code. So we're using reduce against the none here, and here it is the aggregator. So this is the last, the reduced value from the last step, and it will resolve the current item. So finally, it will actually resolve all the items. So we can clearly see the third solution, the complexity, the time complexity is actually n. And because there's no space to save it, so the space complexity is 0. Let's sum up. So we got 3 solutions. So the first one is very bad, which the complexity is n2. The second one, we use the dictionary to save the occurrence. So the time complexity is n, but the space complexity is n2. So the third one, which is using a bitwise solution, and the time complexity is n, and then we don't need to add extra space to do it.